Has there ever been a math problem or confusing word in a book that has confused you? Have you ever become extremely frustrated by the fact that you have no idea what you are trying to solve? After putting in all your effort into thinking what the answer may be, have you come up short? Did you say there must be no answer to this question, or did you say this must be a paradox? Well, if you were conducting the Schrodinger's cat thought experiment, then you were correct. Brace yourselves as I attempt to understand, answer, and explain the Schrodinger's cat thought experiment, the most hard to understand thought experiment in existence. So first of all, we're going to give some history surrounding Schrodinger's cat. The creator of this thought experiment, his name was Erwin Schrödinger. He was one of the fathers of the Copenhagen Interpretation. He's also known to be responsible for developing something called the Schrodinger's wave function, or the Schrodinger's wave equation. Schrodinger's function is basically the quantum mechanics version of Newton's second law. If you know what Newton's second law is, it's force equals mass times acceleration. Schrodinger's wave function predicts that the future actions of subatomic particles and solutions to this equation can explain anything from the smallest quantum systems in the universe to the universe, theoretically, the universe itself. This equation is important because it will be used later in the episode. You don't have to know the entire equation, you just have to know that it exists. When the Copenhagen Interpretation, which states that all particles in quantum mechanics are in superposition until observed, superposition is basically just the term used to describe a quantum system that is in multiple states at once. So for example, an electron, when observed in the double-slit experiment, can act both like a wave and a particle. Yeah, an electron, what we consider an elementary particle, can also act like a wave. Until this quantum system is observed, it remains in superposition, but once it is observed, it's basically forced to choose a state. Schrödinger devised this mind-numbing thought experiment in an attempt to explain this turn your brain into mush concept. So obviously, being a thought experiment, you're only going to be imagining the materials that you obtain to actually perform the experiment. Understand that because this is a thought experiment, if you try to do the experiment in real life, you wouldn't get accurate results. Because remember, this is to exemplify quantum mechanics, not the death of a cat. So unless you are a psychopath and you want to kill a bunch of cats, you shouldn't do this experiment. I mean, if you're a psychopath and you want to kill a bunch of cats, whatever. But if you're not a psychopath, honestly, even if you are a psychopath, don't kill cats. Why would you kill cats? I'm talking to you. Like, why would you kill cats? Cats are cute. They're not cute. There are a few things that you will need in this crazy thought experiment. One of them is obviously a cat. Second, a radioactive substance. So it could be anything from radon to plutonium to francium to uranium to radium to whatever other radioactive material you can think of. And another thing you will need is an internal monitor to detect radioactive decay. So in the actual atoms, like for example, we'll be using uranium in this episode to explain the Schrödinger's cat thought experiment. You need something to measure the radioactive decay to see if it's happening. And this is also known as a Geiger counter. Basically just measures the radioactive decay in particles, in atoms, not particles. You also need a flask of poison. I'm going to use cyanide because most people use cyanide. Even Schrödinger himself in the original thought experiment used cyanide. So, but you can use anything. You can use ricin. I don't really honestly know any other poisons. I'm not really much of a murderer. I hate to break it to you guys, but I'm not really much of a murderer. So I don't know really that much about poison. Another thing you need is a hammer. A hammer is going to break the cyanide, the flask of cyanide, the vial of cyanide. And then you also need a lever attached to both the hammer and the detector. The thought experiment itself is quite easy to understand, and what is really difficult is just the interpretations surrounding this insane thought experiment, and also like what is happening below the actual thought experiment itself. For now, we will just explain like what is actually going on, like what the thought experiment itself is, and then we'll get into like what it means, what it's supposed to exemplify, what interpretations it could it has had, because it's technically considered a paradox, because we don't really know what will happen when the waveform collapses, and I'll discuss that later. I'll teach you guys about that in a minute. So basically, the Geiger counter is trying to detect if there's any radioactive decay occurring in the uranium atoms in this thought experiment. If the counter detects radioactive decay occurring within the uranium, the lever will fall, releasing the hammer onto the cyanide, onto the vial of cyanide. The vial of cyanide will crack and break. The cyanide will be released, and the cat will inhale the cyanide and will die. Now, on the other hand, if the Geiger counter does not detect any radioactive decay, the exact opposite will happen. Nothing will happen, and the cat will not die. So, everyone who loves cats out there, this is for you. It sounds easy enough, right? Like, the thought experiment is performed quite easily. I mean, this is not something that's supposed to be done at home. Like, you're not going to get any actual scientific results from this outside of killing a cat. So, I mean, unless you're killing cats for science experiments, you're not really doing much science. So just remember that it's a thought experiment. There's still a lot more we have to talk about. So if I were you, get ready, prepare your brain, and hope to the universe that your brain does not turn into mush, because mine certainly did. As I said earlier, all quantum particles, when not observed, are bound within the realms of Schrödinger's wave function. As indicated by the Copenhagen Interpretation, when these quantum particles are not observed, they are in what is known as superposition, in meaning that the particle can be in multiple states at once. Now, I'm not talking about states of matter, I'm talking about what it actually is. So like, for example, an electron can act like a wave and act like a particle at the same time. This is further exemplified by a very famous experiment called the Double-Slit Experiment. It was performed originally in 1801 by an English physicist, Thomas Young, to attempt to prove that light was a wave, that photons are waves, that light itself is a wave, and obviously he was correct. Quantum physicists use it themselves to explain how a subatomic particle, like an electron, can act like a wave and still create what is known as an interference pattern. One significant problem in quantum mechanics is that measurement is impossible. Once a physicist attempts to measure the particle with any means necessary, pretty much, the waveform in the particle that was previously in superposition will immediately collapse. Waveform collapse is basically the transformation of, and I quote, a spread out wave function to a localized particle. This is from one of my links in the description by Quantum Physics Lady. You will see how this is important when looking at what is happening in the thought experiment. Schrödinger's cat is meant specifically to exemplify and simplify what is happening at the quantum level. Obviously, you're not going to get the scientific results by killing the cat. Based on the Copenhagen Interpretation, the cat, as it is in superposition because it hasn't yet been observed, is both dead and alive. So think of the electron, for an example. The electron that is in superposition is both a wave and a particle at the same time. Now, increase the size of that to the cat. When the cat is in that box, it is either dead or alive, but when it is in superposition, it is both dead and alive. It's meant to, that kind of bridges it between quantum physics and the thought experiment itself. It is only when the box is opened and the measurement, aka the conscious observer viewing it, when the waveform collapses and, at least based on the Copenhagen Interpretation, it's bounded by the laws of probability what will happen next. So let's say there's a 50-50 chance that the cat is either dead or alive. So there's a 50% chance it's dead, there's a 50% chance it's alive. Let's say the observer opened the box to see a dead cat. Now, where would the alive cat in superposition go? What would happen here? So again, we are going to talk about the interpretations of this very soon. So basically, under the Copenhagen Interpretation, basically everything's just gonna go down to probability. So if there's a 50-50 chance that it'll be either dead or alive, there's a 50-50 chance it'll either be dead or alive. There's no splitting, there's no crazy events that occur. It kind of chooses one thing and just leaves it at that. And that kind of seems boring to me, but you can form your own opinion for yourself. The various interpretations and the fact that we don't really know that much about quantum physics yet is why this thought experiment is generally considered to be a paradox. And we'll show you how there's the interpretations kind of conflict each other. The first of the interpretations is also known as the Copenhagen Interpretation. I've mentioned this multiple times earlier. It holds the scientific consensus, without a doubt, and it is the principal theory in quantum mechanics. In this interpretation, once observed, a quantum system previously in superposition abandons its superposition once the waveform collapses, akin to when it is observed. The system becomes either one or the other of the states it had previously been in, or if there are 11 states, it'd be one of the 11. In this situation, like with the thought experiment, the cat will either be dead or alive. Basically, when the person opens the box, the waveform will collapse and the cat will be either dead or alive. A problem with this interpretation, and also with the thought experiment, was actually mentioned by one of the fathers of the Copenhagen Interpretation, Niels Bohr. I know you guys have heard of him. Bohr did not consider the wave function an actual physical phenomenon, but rather a statistical tool. Even so, the waveform of the system in quantum mechanics would collapse long before a conscious observer opened the box. In this situation, the Geiger counter would be a form of measurement, and the waveform would collapse long before the box was opened. Because it doesn't necessarily take a conscious observer, it takes an observer in general. And in that situation, the Geiger counter is a measurement tool. And also, it was explained in the websites that I looked at that the cat itself was technically a conscious observer. So we need to kind of like take that out. Like, remember, this is a thought experiment. Not everything's meant to be taken literally. Any measurement, whether made by a conscious observer or an unconscious detector, will always collapse the waveform of a quantum system. The next interpretation I have for you guys is just so much more interesting than the Copenhagen Interpretation. I love the Copenhagen Interpretation, but this one is so entertaining in my opinion. I've been waiting to tell you guys about this one for a long time. If you watch the podcast, you know that I really wanted to talk about this because I was leading up to it like since the beginning of the episode. The Many Worlds Interpretation. Speaking in terms of the general population, not the scientific consensus, let me be real on that. The Many Worlds Interpretation is easily the most popular of all the interpretations of the Schrödinger's cat thought experiment. Formulated by physicist Hugh Everett, this interpretation does not single out the observation of a quantum system as a special event. Rather, it states that when the waveform collapses, both the alive and dead forms of the cat will persist in what is known as quantum decoherence. So they will be decoherent from each other. Basically, when the box is open and the event is observed, one alternate reality of the observer would see a dead cat, and the other reality of the observer, and meaning like if I were to look in the box and see a cat, would see an alive cat. So basically every single time an event occurred, the reality would split. So one of the realities in which the girl whose number I asked for said yes, and the other, the one that I experienced, in which she said no. One problem with this interpretation is that, at least as of now, the theory is widely considered to be unfalsifiable, kind of unjustifiable. An unfalsifiable claim is generally considered pseudoscience, at least in the scientific world. But if it is possible to prove or disprove this in the future, or if we begin to agree with Sean Carroll, then yes, it'll be falsifiable, so we will be able to test it. Now, I don't actually know, I'm not completely sure if we're able to test it yet, but there's a lot of controversy with it. This is a very controversial subject, no question. However, proponents of this theory, like for example, Sean Carroll, he is a professor of physics at Caltech. He claims that many worlds is proven by mathematical formulas, which at least it somewhat is, and can be physically falsifiable. I'm not sure how. After 30 minutes of reading what he was talking about, I still had no idea. But again, I have links in the description if you want to find out for yourself. There was another thought experiment that was actually built to explain many worlds. And when I read up on this experiment, I genuinely believed that some of these people, some of these physicists, are mad scientists. Just wait. Listen to what this thought experiment is called. It is called the quantum suicide machine. They couldn't make it something different. It had to be killing yourself. So imagine a gun pointed at a conscious observer. So imagine there's a gun pointed at me. So like where this camera is, there's a gun right there. And every minute, there's a 50-50 chance that the gun will go off, that the waveform in the gun will collapse. Just imagine that. And I will get shot straight in the head, 0% chance of living. So it's virtually impossible. So I will be immediately shot dead, 50% chance every single minute. If superposition and the many worlds interpretation are apply in this thought experiment, the waveform would collapse every single time, split up into two different realities, one in which I would survive, and the other in which I would die immediately in a painless death from killing myself, which does not sound good anyways. The waveform collapse would continue to occur. It would continue to occur forever, and considering that there is no such thing as a 100% probability in this situation, I will survive. At least one part of me, one reality of me, will continue to survive forever. This is also referred to as quantum immortality. So as long as a probability remains, living conscious observer will be able to realize this. On the other hand, if the Copenhagen interpretation is correct, then there will be a 50% chance of me dying after 1 minute, a 75% chance of me dying after 2 minutes, an 87.5% chance of me dying after 3 minutes, around 95% chance of me dying after 94.5% chance of me dying after 4 minutes, and so on. Yeah, there are many more interpretations in the thought experiment. I just thought I'd give the main ones. But yeah, so I have links down in the description that will talk about some of the other interpretations. It is without question that quantum mechanics is easily one of the most profoundly confusing subjects humans have ever stumbled upon. I am generally good at understanding advanced mathematical and scientific concepts, but this did not apply at all. The studying I did to understand this concept took me at least 3 hours, and probably even more than that. It's definitely a difficult subject, and I highly recommend that you guys read up a little more on what is actually going on. Still, the wondrous confusion brought about by quantum mechanics further exemplifies the beauty of reality in our universe. I can assure you that if you decide to click the links in the description, you will feel very wondrously confused. And honestly, once you figure it out, you will feel an amazing feeling. Once I figured it out, it was the most magical feeling ever. So anyways, thank you all for listening. And as always, have a good morning, a good afternoon, a good evening, and a good night. Take care and stay curious, everyone.